7.2, finding a shorter side. To find a shorter side, we use the same method, only we have to use subtraction. So if you remember the method for working out Pythagoras theorem, we had to label the sides. Then we substituted into a squared plus b squared equals c squared, where c squared was the hypotenuse. And then we substituted in our values and we worked it out. So we'll still do the same thing. So in a squared plus b squared equals c squared, remember c is the hypotenuse, which is the side opposite the right angle. And the other two sides, it doesn't really matter. So the side opposite the right angle in the first example is going to be the side labelled 8. And then we're going to have a and b. So then we write out Pythagoras theorem, a squared plus b squared equals c squared. And we substitute in our values. So a is 6, b is b, and c is 8 squared. So we put in our values. So 6 squared is 36, plus b squared equals 64. And now what we'll do is we'll take away 36 from both sides. And then what we'll be left with is b squared is equal to 28. And then we'll do the square root of that. So b is going to be the square root of 28. So b works out 5.29 centimetres to 2 decimal places. In the next example then, we do the same again. So we're going to label the three sides. The hypotenuse is the one opposite the right angle, so that's 82 millimetres. And then a and b. So we've got a squared plus b squared equals c squared. We'll substitute in the values. So a was 80 squared plus b squared equals 82 squared. 80 squared is 6,400 plus b squared is 6,724. Then we take away 6,400 from both sides. And we get b squared equals 324. And then b is going to be the square root of 324. So b is 18 millimetres. In this next example, we need to find this middle side here. Now what we've got is one large right angle triangle, and inside it is a smaller right angle triangle. So we're going to have to look at Pythagoras theorem twice here. So first of all, I'm going to draw out the larger right angle triangle, which is a hypotenuse of 65 and the base of 25. And I'm going to call this, that's the one I'm going to find first of all, because if I can get that on the bigger triangle, so if I can find this side, then I can use Pythagoras theorem on the inside triangle to work out the value of x. Remember, I can't use Pythagoras theorem in this triangle because it's not a right angle. So Pythagoras theorem only works for a right angle triangle, so we can use Pythagoras theorem to work out the height of the larger triangle, and then that's also the height of the smaller triangle, and then we'll be able to use it for that. So within this, we have to label the sides, A, B, and C. C is the hypotenuse, and A and B are the two other sides. And then we do a squared plus b squared equals c squared. Substitute in the values. So we've got a squared plus b squared, so that's 25 squared, equals 65 squared. A squared plus 625 is equal to 4,225. So now I need to take away 625 from both sides. And I get that a squared is equal to 3,600. And then a is going to be the square root of 3,600. So a is going to be 60. So I now know that the height is 60 centimeters. So what we're going to look at is this small, thinner triangle, which is contained inside it, which now has a height of 60 and a base length of 11, and we're trying to find x. So the first thing I need to do is label the sides. C is the hypotenuse, the one up to the right angle, and A and B are the other two. So I've got a squared plus b squared equals c squared. So I've labelled the sides and I've put in Pythagoras Theorem. Now I substitute in, and I'm going to have 11 squared plus 60 squared equals x squared. 11 squared is 121 plus 3,600 equals x squared. 3,721 equals x squared. Now notice I didn't subtract here. So in the previous example I subtracted. That's because I needed to move the 625 to the other side to leave a squared on its own. But here x squared is already on its own, so we don't have to do anything. We just add them as it's telling us to do. So now we need to find the square root of 3,721 to find the value of x. And because it's the hypotenuse, it's the longest side of the triangle, so we would expect the answer to be bigger than 60, which works out to be 61. So 61 is x, so that means that x equals 61 centimeters. And then finally, a man has a ladder of 240 centimeters long. He places it against a wall. For safety, the bottom of the ladder must be 95 centimeters from the base of the wall. How high up the wall must it reach? So let's draw a picture for that. We've got our wall, which will stand perpendicular to the ground. And we've got a ladder, which is 240 centimeters long. It's going to rest against the wall. And the base must be 95 centimeters away from the wall. And the ladder itself was 240 centimeters. And we want to find the height, which is the unknown. And the wall was perpendicular to the ground. So what we've got is a right angled triangle. We can use Pythagoras Theorem. The hypotenuse is C, and the other two sides are A and B. We write out Pythagoras Theorem, a squared plus b squared equals c squared. Sub in our values. So we've got 95 squared plus x squared equals 240 squared. So using our calculator, we get that 95 squared is 9,025 plus x squared equals 57,600. Looking at the left hand side, we've got 9,025 plus x squared, so we can't do that. So to get x squared on its own, we need to get rid of the 9,025, so we need to subtract that from both sides. So minus 9025, minus 9025, and on the left hand side, x squared will just be left, and on the right hand side, four 8,575, and x is the square root of that, and that works out to be 220.4 centimeters, and that makes sense because it's smaller than the hypotenuse, than the ladder, so that looks good. So the ladder will reach 220.4 centimeters up the wall.